अच्छा, ये थोड़ा थोड़ा रिकैप कर लेते हैं कि हमने क्या किया था। कि ठीक है, जस्ट रिकैप कि वी डिड अच्छा, वी डिड द रिएक्शंस ऑफ वाटर। ठीक है, वी डिड द रिएक्शंस with water. Okay, where told you that uh, these two, the top two, they're very reactive, ठीक है, explosively reactive, and you had to know the details about the reaction with water. ठीक है, sodium reacts with water to form a strong alkali and produces hydrogen gas. There's a lot of explosive reaction. Sodium fizzes and on the surface, floats on the surface, vigorous effervescence, bubbles are produced. So effervescence, ठीक है, effervescence means bubbles. And a strong alkali is formed and the sodium melts and catches fire. There's a lot of heat produced and it might eventually explode as well. ठीक है. Calcium, slightly less reactive, so mild reaction. Magnesium would then go on to react with almost no reaction with water. It will go on to react with steam at high temperatures. और क्या था? Aluminium. We talked about aluminium that it did not react at all, even though it is somewhat reactive, but because it would form an oxide layer on the top, which is tough, non-porous, unreactive, and that would kind of protect it. So Skoda, we kind of linked it with the users as well. That's why it's often used as food containers and cans, etc., in car bodies, bicycles, because it's never going to rust. Its top layer will rust, will react with the water or oxygen, but it will then form a coating on top, which would kind of prevent any further reaction. As I said, we did rusting of iron in detail. Okay, water and moisture and air is needed for rusting to happen, and और क्या था? So there were a couple of methods. Barrier method, which is you coat the metal with something like grease, oil, wax, paint, or the rusting would can be prevented, or it was sacrificial protection that you attach something that is more reactive so that it starts giving it electrons. So iron will not be able to lose electrons in the presence of this other thing. अच्छा, और क्या था कि we cathodic protection that we did. Then we did reactions with acid, and that was pretty simple. That the reactions with acid is that the top ones will explosively react with acids. A metal reacts with acid and produces salt plus hydrogen gas. ये जो बीच वाले ना, the middle ones, they have a very moderate and normal reaction. So you can do those in the lab. Magnesium, aluminium, zinc, iron, and tin. ठीक है, you call them mazit metals. So they kind of have pretty normal reactions. And the bottom ones, especially the ones below H, they have no reaction with dilute acids. They can react with very concentrated acids, but definitely no reaction with dilute acids. So that was done. Reactions with acids. Okay, we were done with reactions with acids. And the next season, that's about again reactivity series, but that's about displacement reactions. Okay, we're going to learn about displacement reactions. So uh, these are basically redox reactions where one metal atom gains electrons, the other one loses electrons. For example, if I have sodium and I have AlCl3, sodium is more reactive than Al. ठीक है, that's more reactive than Al. So sodium would knock out the Al and take its place. So AlCl3 will turn into NaCl. But the formula you have to make again, it's Na plus 1, Cl is minus 1, so it's going to be NaCl. And the Al is going to get knocked out, and you can balance it. 3Cls, and so you're going to have 3Cls. That would make it 3Na, and I guess that's it. So a more reactive metal. So more reactive metal displaces, or there's another word for that. It reduces. More reactive metal reduces a less reactive metal or displaces a less reactive metal? So let me explain this. You had Na and there was 3Na. And AlCl3. AlCl3 mein Al is actually an ion. It's got a +3 charge, and the product is 3NaCl with Na is actually +1, and you have Al. So this is the ionic equation. Okay, if you don't know what the ionic equation is, I can quickly tell you how to write the ionic equation. Okay, you write down the states. Sodium metal is a solid. AlCl3, Cl compounds are all soluble except for silver and lead. Okay, according to the solubility table, ये जो silver compounds Cl compounds are all soluble except for, so this is soluble. Na is a group 1 compound. Group 1 compounds are always soluble. Group 1 compounds are very soluble. ठीक है, solubility table में ना it's mentioned that इसको क्या हुआ है? अच्छा, so solubility table, group 1 compounds are all soluble, and hopefully you know that NaCl is soluble and aluminum is a solid. So how do you write the Ionic equation? The Ionic equation is written in this way: okay, you don't do anything to the things that are solids. So you keep Na solid as it is. AlCl3 is aqueous over here, which means okay, AlCl3 will dissociate it. When you mix it in water, it will dissociate into its ions. So it will mix and it will split into its ions. So it's going to produce 3Cl ions and 1Al ion. Okay, all of them will dissociate. And so the NaCl is also, it's also very soluble. So it will also, anything that is soluble will, pani mein, this ions will, in water, the ions will get scattered. So 3Na plus 1 and 3Cl minus 1, they'll all dissociate. And then you have aluminum solid. So you're going to write aluminum solid as it is. Okay. It will be Na solid as it is. We did ionic equation a long time back. I said, like, I'm just going to explain this again for ionic equation. Okay, in ionic equation, you dissociate ionic compounds that are soluble in water because their ions will get completely scattered in water. Okay, so the ions will no longer be together. So, which is why my AlCl3, if it's aqueous, the ions are not going to be together. They'll actually be roaming around in aqueous solution. Okay. Yeah, the clear, is this clear? Fatma, Taha, Bahad,
Yes, sir.
Bahania, is this clear? So anything that is aqueous, its ions will dissociate. Acha, ab inme se na, you look at the whole equation now and tell me which one is the spectator ion. It's the ion which is not doing anything. Yani it's the same exactly on the left side, and it looks exactly the same on the right side. ठीक है, Shanze, it's Cl ions. Cl ions are really not doing anything. Cl ions aqueous, and in the products you still have Cl ions aqueous. That means in the whole reaction they pretty much didn't do anything. The other ones they did. Na was a solid, and over here Na is now +1 and it's aqueous. So कुछ ना कुछ किया उसने. Al is +3 aqueous. On the other hand, Al is solid, right? So that's how you write the ionic equation. You get rid of the spectator ion. So the remaining equation, Na solid plus Al +3 aqueous. I'm not going to write Cl ions because they're not doing anything. And you've got 3Na +1 aqueous. And you've got Al, which is solid. So that's your ionic equation. Okay, so remember this. Okay, in chemistry, you always have two types of equation. You have an actual equation, which is upper this one. AlCl3, Na comes in, knocks out, displaces Al, right? And forms NaCl plus Al. So more reactive displaces less reactive. And you can convert the same equation. Both of them are exactly the same equation, except that one of them is your ionic equation of the same reaction. Okay? So it removes the spectatorines, which pretty much are not doing anything. ठीक है? ये clear है सारों को?
Yes, sir.
अच्छा, खैर, coming back to the same thing, a more reactive metal displaces a less reactive metal, or the other way around is the same statement is it reduces a less reactive metal. So you can have a look. Okay, it is actually reducing it. A more reactive one, which is sodium. Sodium is the one that's getting oxidized. Oxidized का मतलब क्या था कि it loses electrons. It became +1, ठीक है? So whenever something becomes +1 or charge increases, that means it's losing electrons. The other one, Al plus 3 turns into Al, that means it is gaining electrons, which means that it got reduced. So a more reactive, which is sodium over here, reduces a less reactive metal. क्योंकि सोडियम, अच्छा, तो उसके पीछे लॉजिक ये है कि sodium is the one that is more reactive, so it likes to lose electrons. It wants to lose electrons, so it's going to give its electrons to the other one, which is the less reactive one. So usko phir the only option for Al is to gain electrons, and it will get reduced. So whenever you have a less reactive metal and you put it in front of a more reactive metal, the more reactive metal really likes to lose electrons. So it will give its electrons to the less reactive one, and the less reactive one would gain electrons and turn back into the original state, which is the original metal, the neutral metal. So is this clear? The use of the two words displaces, reduces, same thing. Is this clear? ये clear है?
Yes, sir.
So some more examples. If I have calcium reacting with, let's say, FeSO4. Now calcium is more reactive than Fe. So calcium would displace it. It will become CSO4 plus, and Fe will get knocked out. Or the other way, the Ionic equation for this is, the other way of looking at this equation is that you had Fe plus 2. So what happened was that calcium wanted to lose electrons. So calcium became +2, and Fe plus 2 was the one that had to gain electrons. So it became neutral again. So calcium got oxidized because it was the more reactive one. It wanted to lose electrons, and Fe plus 2 had to be, it had to gain electrons. It had no choice. Okay? So just remember, more reactive displaces a less reactive metal from its from what? From its compounds or solutions, ठीक है? ठीक है, तो छोटी सी चीज है, but is this, ये क्या क्वेश्चन है? वन सेकंड. शान से ये कि सी ए ज्यादा रिएक्टिव है ना? तो एक तो सिंपल तरीका है टू रिमेम्बर दिस इज दैट सी इज मोर रिएक्टिव, तो सी ए एंड आयरन इज लेस रिएक्टिव. रिएक्टिविटी सी को देखो ना, इट्स के एन ए सी ए एम जी. So Ca is right at the top, MgAl, Zn, Fe. Fe is like somewhere at the bottom, ठीक है? So Ca, a more reactive metal, will knock out Fe, which is the less reactive one, and take its place. और Fe को बाहर निकाल देगा because Ca is more reactive. शादी पहली वाली, well, the first thing, is that clear? Or the other way to think about it is the same thing, but the other way, the terms would be different. कि Ca is more reactive, so Ca wants to lose electrons, right? A more reactive one wants to, what does it want to do? It wants to lose electrons. लिख देते हैं यहाँ पे. So more reactive. So what does it want to do? It wants to, a more reactive metal always wants to lose electrons. So if you put Ca next to Fe, so C is more reactive. So what it will do is it will lose electrons and it will give its electrons to Fe. So Fe plus 2 वापस neutral हो गया, ठीक है? It became neutral. and Ca turn into an ion. ठीक है, शांति, क्लियर है? और दोनों बातें एक ही हैं बस, except कि they're just different ways of looking at it. More reactive displaces a less reactive, right? Or you can say a more reactive reduces a less reactive metal. ठीक है, ये क्लियर है? कोई और कंफ्यूजन तो नहीं है इसके बारे में? जस्ट बी केयरफुल विद द टर्म्स। था इज दिस क्लियर? बात हानिया क्लियर है? जैनब क्लियर है?
Yes, sir.
Yes, sir.
ओके, अच्छा, नेक्स्ट वन. So more reactive displaces a less reactive, or a more reactive reduces a less reactive. Now the next one, we're going to apply this thing, and it's going to get applied to extraction of metals. Again, this is not the laboratory extraction of metals. It's how industrially metals are going to be extracted. The first thing is you have the reactivity series. So we have the reactivity series. One side is very unreactive, the other side is very, very reactive. Now, the very first thing is we're going to start at the bottom. ठीक है, और उसमें ना we actually did some of them, but especially the ones that are like very unreactive. So we already did actually copper, we already did, but we're going to just do it again because we're going to study all the metals. So these metals at the bottom, they're very unreactive. So the first way to actually get these metals is that they're found in the native state. Found in, बाकियों को बाद में डिस्कस करेंगे, एक सेकेंड. अच्छा, so they're found in the native original state. Example क्या है? Example is gold nuggets, right? You just find them. There's a rock and it's got gold nuggets, right? Or gold ores. ठीक है, there's going to be a rock and it's just going to have pure gold in it, right? So you don't have to do any chemical reaction. Same with copper, silver as well. So also copper in its original state can be found in copper ores. So the only thing that is needed is if you're finding a very unreactive metal is you just do purification. ठीक है, so only thing needed is, because obviously the gold nugget that you find in a rock is going to have dust or sand or something trapped inside it, right? So the impure metal can be purified. You just need to purify it via electrolysis. That's it. So we already did that early on. So I'm just going to quickly do this. If you have an impure copper, let's say you find a rock that has impure copper in it, you're going to make it the anode. And let's say you're going to make it the anode. और दूसरी साइड पे ना, on the other side, you're going to get pure copper. Do you remember we already did this in electrolysis? I'm just going to repeat what we चलो ठीक है, ऐसे बीके बन गए. And this is going to have copper sulfate aqueous. So copper sulfate aqueous, this is my negative cathode. That's my positive anode. And what are the ions in copper sulfate? It's got copper ions. Okay, the positive ions. Negative ions are going to get attracted to anode. H plus 1, which is going to go to cathode, and you're going to have OH minus 1 ions. TK battery is going to send electrons. So who's going to gain electrons, copper or H? So according to the reactivity series, if you remember electrolysis, it's the less reactive one that gains electrons. So copper plus 2 is the one that gains electrons, and it becomes pure copper. And you start seeing a layer of pure copper forming on top, ठीक है, on top of the cathode. ठीक है, electrons are and copper ions or H plus 1 of these has to gain electrons. And on the other side, the electrons are going to be removed. And who loses electrons? You've got these negative ions that can lose electrons, or it could be the copper metal itself that loses electrons, which would be the copper metal. वो हमने पढ़ा था electrolysis में, it's always if you made the anode out of copper metal, then it will be the one that would lose electrons. So it will start turning into ions, it will start to dissolve. So a lot of copper ions will be formed. So on one side, copper ions are getting formed. So copper dissolves from the ore. And on the other side, copper ions get deposited. They get attracted to the cathode, which is negatively charged. And eventually what they do, they form the copper metal back again. So on one side, you're gonna place your impure copper, which is going to be placed on this side, or battery is going to pull electrons out of it. It will start turning into positive ions. It will start going into the solution. The copper metal will start to form copper ions, and all those copper ions are going to get attracted to the negative cathode over here. And when they get attracted to this, the battery is going to give the electrons to it, and they're going to start gaining electrons, and they'll turn back into copper. So आहिस्ता आहिस्ता क्या होगा, all the copper on one side will dissolve and it will end up on the right side, and over here you'll just get pure copper. So the idea is that for impure metals, uh, you will get the metals in their original state. They would very rarely form compounds. Gold would not be forming compounds. Gold will be found in the form of gold, except that the gold rock would have a lot of other things as well. So you to get the metal out of that rock, you would have to do purification by electrolysis. ठीक है, ये clear है? Yeah, is this clear? फातिमा, बाकियों को clear है सबको? ज़ैनब clear है? हानिया?
Yes, sir.
Ahmed? So this is what we had earlier done. There's a few more reactions over here, and that is that we did copper. So sometimes what happens is that copper is found in the form of a compound. Copper within the unreactive metals. Copper is the one that has a chance. It's slightly reactive. It has very, very slightly reactive. So sometimes what happens is that the copper ore found would be in the form of a compound. So there are two things that you could do. So if copper is found as a compound, then what you're going to do So example is if it's found in the form of not copper, but a compound like copper carbonate, which is green in color. So the first thing is you're gonna dissolve the ore in an acid, like sulfuric acid. So the copper carbonate would react with sulfuric acid and it will form. You can remember carbonates would react and they would form salt, water, and carbon dioxide. So it would form copper sulfate plus water plus carbon dioxide. Do you remember there were four reactions that we studied in acid-base salts? One was metal plus acid produces salt plus hydrogen gas. Metal oxide plus acid produces salt plus water. Metal hydroxide plus acid produces salt plus water as well. And metal carbonate plus acid जो होता है ना, that produces salt, water, and carbon dioxide. So if copper is found in the form of an ore, the copper carbonate, you're going to dissolve it in sulfuric acid and you will turn it into copper sulfate. वो जब बन जाएगा ना, again you'll just do electrolysis. ठीक है, of an aqueous solution. अच्छा ये So this electrolysis is simple. You again, it's kind of the same. It's copper sulfate aqueous, copper ions, SO4 minus two ions on the other side, and aqueous is the water says you're getting two ions. Again, you're going to get copper at the cathode, because copper ions are going to get attracted to the negative cathode. And they're going to go over there and they're going to gain electrons and they will form copper back again. ठीक है? तो electrolysis तब भी करना है if it's found in the form of an ore and a compound specifically, you'll just react the compound with, let's say, sulfuric acid. You're going to dissolve it. It will form a salt. And if it's an aqueous solution, you just do electrolysis and you'll still get copper. ठीक है? So copper would mostly be found in this way. There's another way of अच्छा इस केस में it doesn't really matter. It's you can have inert electrodes. क्योंकि उधर कैथोड पे ना कॉपर बनना ही बनना है. ठीक है. So you can make it out of copper as well, uh, but inert electrodes, that's fine. Graphite, etc. Platinum would just be too expensive, but you can use those as well. शादी clear है? हानिया clear है?
Yes,
ताहा,
sir.
अहमद, ठीक है. अच्छा, so remember, there's one other way of extracting copper. There's one more way of extracting copper. ठीक है, let's assume that it's made out of copper carbonate. There's a thing that we can do is second method of extracting, and that's displacement. This is the second method of getting copper from copper carbonate. That is something that you can probably do in the lab as well. So you take the copper carbonate is decomposed. You heat it strongly. I say it is decomposed. So what happens is it is heated strongly. So when you take copper carbonate and you heat it strongly, it will break down and it will produce a black oxide, which is copper oxide, and water is going to be produced. तो ये green है. ठीक है, remember you need to know the colors of copper compounds. That's very important. And this is a black oxide. ठीक है. And then if you look at the reactivity series, कहाँ की reactivity series? This one. You would notice that hydrogen gas is more reactive than copper. ठीक है, so hydrogen gas over here is more reactive than, it's more reactive than copper. So all you have to do is, ये जो last method है, you take the copper oxide, ठीक है, maybe in a tube, and तो आपने उस rock को ना, you strongly heated it and it broke down and ended up producing, अच्छा ये water गलत होगा, water is not, carbon dioxide is there. अच्छा, so you're going to take some copper oxide and you're going to blow hydrogen gas on top of it. So that is going to be blown, and you're going to heat this copper oxide very strongly. So a displacement reaction would happen. The displacement reaction is since hydrogen is more reactive than copper, ठीक है, reactivity series में hydrogen is more reactive. So hydrogen is going to displace it. Hydrogen is going to take away the oxygen from copper, and copper is going to get knocked out. ठीक है, तो वो जो displacement reaction है, the more, so this is more reactive, and it will eventually knock out the, or take away the oxygen. So यहाँ पे ना water vapors are going to be produced, and eventually the copper oxide will turn into orange brown copper. ठीक है, तो ये मेरा last method of copper extraction का कि uh, and again that's important in ADP as well. Like they might ask you कि भाई how do you get copper from copper carbonate? उसको पहले strongly heat करो, the copper carbonate keep heating it until all of it turns into copper oxide, this black solid, and it breaks down. ठीक है, carbon dioxide gets separated. And then take that copper oxide and blow hydrogen gas over it. Hydrogen is more reactive in the reactivity series, so hydrogen gas will steal all the oxygens from copper and will form water, and copper would be left alone. ठीक है, so pure copper metal would be produced. और इसको लिखने का तरीका ये कि hydrogen would reduce the copper. ठीक है, is this clear? ये clear है सारों को? Hamid clear है, हानिया?
Yes. Yes.
अच्छा, तो remember copper की कहानी बहुत important है because copper, remember this copper is like their favorite, ठीक है? Chemistry में copper is like everywhere. So तीन methods of extracting copper. One is that you just find it and you just find it and you just have to purify it. ठीक है, so that is purification of copper. The other one is you find the compound, not the copper itself, but you find the compound. In that case, you take the compound and you dissolve it in an acid, and then you electrolyze it. And the third one is you find the compound, you just heat it strongly so that it breaks down, forms copper oxides, and you then just pass hydrogen gas over it so the oxygen gets stolen and the copper it gets reduced. शानदार, वो पार्ट बस ये कि कॉपर कार्बोनेट को हीट किया ना तो it formed copper oxide, right? It broke down, it decomposed. So when you pass hydrogen over it, hydrogen in the reactivity series is higher up, is more reactive. ठीक है, it's more reactive. तो वो क्या करेगा उसके, it will steal the oxygens from copper and it will become water and copper would be left alone. So आपका जो beaker होगा, जो भी चीज होगी, ये tube होगी, it will just contain copper at the end because all the oxidants will be stolen by the more reactive hydrogen. ठीक है? शांति clear है? और remember ATP, it's a very favorite question. वो जो last 6 mark का question आता है ना ATP में, they ask this a lot. I mean, where you have to design an experiment. Sometimes they find impure copper, sometimes they find copper in the form of a compound, and they ask you, can we design an experiment? How to get copper from it? अच्छा ये तो कॉपर का हो गया एंड उससे जो अगला पार्ट है ना which is this कि you'll have these metals over here between less reactive than zinc but more reactive than H. How do you extract these? So this is what we're going to study. और इसमें ना the important one is iron. Remember, there are a couple of processes which you have to remember. जैसा ये copper का था, you have to remember that. But they're not going to ask you about silver or any other. ये नीचे वालों में से ना, remember this is going to be divided into 3 parts. इसके साथ जांच रहे हैं. इनमें से ना they'll probably just ask you about copper. ठीक है? Then these middle ones, they'll ask you mostly about the extraction of iron. तो इधर मैं method लिख लेता हूँ कि how are they going to get extracted? It's going to be called, the method is called reduction with carbon. वो जो method है ना, we will study that method in detail, which is extraction of iron basically, which we are going to study. लेकिन we'll study zinc as well. ठीक है? तो वो कल करते हैं. ठीक है? अच्छा ठीक है, पिछला क्लियर है, कॉपर का क्लियर है सारों को?
Yes, sir.
चलो ठीक है, कल करते हैं. मैं ये नोट्स भी ना भेज देता हूँ सारे. ठीक है, ग्रुप में. तो
अल्लाह हाफिज सर.
चलो ठीक है. ओके, टेक केयर एवरीवन. अल्लाह हाफिज.